OpenAI recently open sourced its Whisper model, which is a model that takes in a voice recording and then transcribes it into text. But it can also translate that text. So today we'll build a little app that showcases how easy it is to use this Whisper model. I'll try to go a bit quicker, not to make the video too long, and I hope I won't make too many typos by doing so. So let's get the imports done. tkinter as tk, no import custom tkinter as ctk. Those are libraries that I'll be using for the little app interface. Then I'll use sound file as sf and sound device as sd. Thank you, GitHub Copilot. Those will be necessary to record the voice and then save the audio file to your system. And then we'll obviously import the Whisper model, right? And you can pretty much install the Whisper model by simply running this command, right? Just pip install it directly from the repository and you can go ahead and use the model. Now to load the model, it's also again very simple. We define our model, install it with whisper.load, there it is, load model. And then we can just use a keyword like this, model small, right? We can also use medium, I believe, or large and stuff like that, but we'll use small. That alone will be a few hundred megabytes large, and the inference with other models will be too long, and the model is very fine. So let's now create the app. So for that we'll use boilerplate code, which obviously GitHub Copilot can help us a bit with. So that's pretty much the boilerplate, and in the end to run the app, run app is app.mainloop, exactly. So the first thing that we'll just place is the main label, right? This will be a ctk label. Okay, so I quickly went down and coded that, just boilerplate stuff. And let's just also instantly add the record button, right? Because we want to have a button that can record our voice. Exactly, okay, that's called record button, of course. And now I believe we can just run the app and see how it looks. The first time when you run the app, right, and you load the model, it will probably take a while, right, to install the model and cache it. But yeah. Oh, wait a sec. Oh, okay. Little typo. Sometimes GitHub Copilot gets messy when you try to code fast, but in general, I'm a huge fan. Okay, there's the app. Here you can see the app, hopefully at least. And this is our record button, and here is like the CTK label text, which eventually will just be some boilerplate where we will fill in the text that we transcribe or translate. So yeah, this button just does nothing at the moment. So let's quickly implement the functionality for the recording. And I just went ahead and copied the code that I already wrote because this is just not that interesting. This is the frequency to set which the sampling is done, just using the libraries. Boilerplate code, again, nothing special. Saving the audio file, right? And afterwards, after we have saved it, then we can load that audio file into the model and have it do its magic. So let's go ahead and instantly just record our voice, I would say. I mean, I think we should be able to do that, right? I think it might be channel 0. Let's just try out. Okay, no, this again won't work. Wait a second, Boris, you're going too fast. We have to provide the command that the button has to execute. And now we should be able to just run the app and hopefully record our voice. Okay, oh yeah, and what I'm doing for now, it's not very dynamic. I'm just hard coding to record 5 seconds just because it's easier for now. So yeah, let's just go ahead and try it out. Okay, input stream is off, so I guess it can't be 0. I think it should be 1. Hello, my name is Boris. Okay. Hello, my name is Boris. Okay, after fixing one little bug, the recording apparently is done, and we see that here we have the audio file, which is nice. Let's hope that that has worked so far, and now let's get to actually using the model. For that, let's add a new button, which will be the transcribe button. Okay, GitHub Copilot came again to the rescue to make it a bit quicker. But you know, let's just be confident and say that the button works, and just now actually finally implement the logic for transcribing. Okay, for the transcription, we obviously first need to provide the audio file, which in our case is just fine to be a path string. So audio is just called exactly my audio file, blah blah blah. And pretty much the only thing that you will eventually need to do is pass in the results, which will then be model.transcribe, and then we just provide the audio. And why are you crying? Because all along I had this typo again up here. Annoying. So yeah, what we'll also do is we will just provide a few options or keyword arguments to the model to just boost the performance a bit. So we'll just use then options and then define options up here. We'll define it as a dictionary, and we'll then use floating point 16 will be false. You'll also define the language to be English at the moment. We'll just hard code that, and then we'll set the task to transcribe, which is the default task, but we'll see in a minute why this will be important and to be just consistent. Now, the thing is, you don't have to provide this language argument, because it also, if you don't provide any language argument, it will just infer the language, or it will try to predict the language, and it does a really good job doing so. But you know, if you are using some edge case languages, for example, if I would use Bulgarian to then translate that, or transcribe that even, it will be difficult for it to recognize that that is Bulgarian, so I can then just provide Bulgarian, right? In this case it's English, and that should be fine. We can now print the result, but we'll need to extract the text from that, and then we'll just push or print the text to our main label, and that should be it actually. Let's see if that works. Let's just run the, no, obviously it won't work because I'm again so stupid. Well, obviously you can see that the transcribe button is there, but it will do nothing because I again didn't provide the function to call when clicking the button. This isn't going that smooth, huh? Okay, so we here have our app. I don't have to re-record my voice because I also already have the audio file, so let's just click transcribe and hope that everything works and it will do a decent job. What did I say? I believe I say, hello, my name is Boris. I believe. Hello, my name is Boris. There it is. It's transcribed. Amazing. So yeah, that's that. So pretty much you can now see that it works and it's doing a good job. So let's continue quickly, because I think that we're already going way too slow. So now I'll just be copying a few things. Let's also add another button for the translation process, and we'll need a translate function, which is pretty much exactly the same, just using the task translate. That's why I said that you have to provide this task. So now I think we can go ahead and run the app again. Right, okay, translate button. I placed the button. Everything should be fine. Obviously it's not, because I didn't change this stuff here. God, today is not a good day. Please do the things that I want you to do. Okay, now we have everything we need. Oh, yes, okay. So now we can press record. Hallo, mein Name ist Boris. I hope I didn't go too slow, but recording is done. And now we can transcribe, for example, which should... Oh, no, I set the language to English. No, come on. Yeah, I know, I'm sorry. Yeah, language for the transcription is English. Let's just do none for now. Okay, my audio file is still recorded. Let's transcribe. So we finally have here the transcription in German language. The Whisper model was trained on a huge dataset, obviously, and it has a lot of languages that it can translate and transcribe. Some languages are a bit more accurate than others, right? And that pretty much only depends on how extensive the dataset was that they had for the respective language. So English dataset was very good. Oh, you know what? Let me quickly just pull up the paper. So I think they have some plots here. Here you can see how some languages perform better than others. English obviously has a very low error rate, and German is also decent. But if you go right up here, I don't know, are there some languages that I can recognize? Well, there are other languages that are worse, okay? I don't know the exact keys for the languages at the moment, but the point is clear, right? So again, the transcription works in German, and now if I want to translate it, it prints out the correct translation. So I would go ahead and try it out once more and record it in Bulgarian to just see that there it kind of goes down a bit in accuracy, but let's see how it performs. Zdrasti, аз се казвам Борис. Okay. I mean, I'm pretty sure that it won't recognize that it's Bulgarian, or it will infer something different. But we can also try to then define the language in the code and see if it performs better. That's pretty close. I mean, it definitely goes into the right direction, but that's not Bulgarian. I believe Здравствуйте, that's Russian. I believe that's Russian. I mean, now if I translate it, I think it should translate into the correct sentence. I again said, hello, my name is Boris. Okay, well, hello, I'm Boris. It's close enough, right? So we'll end the video in a second. It's a very long video for this little experimentation or fun stuff here. But let's try again and see how the performance will be when defining the language. I hope the key is correct for Bulgarian. But I guess so. So again, we already recorded it, so now we can transcribe. There's no error, so I guess it's correct, the key. Or it just interprets it as none if it's not correct. It's Bulgarian. It correctly interpreted the language, or like transcribed the language. Zdrasti, that's what I said. As se казвам Boris. I think that's not completely correct, but it's not completely correct, but it's basically correct, and I think that the translation will again be spot on. Not really, it's hello, I'm Boris again, but again, it's tomato, right? It's the same. So yeah, I believe that would be enough for today. I hope that this video was really fun. It's the first time that I'm doing this more or less live coding, so it was a bit messy. But yeah, I hope in this video you could see that it's really cool if whenever a huge or large company open sources a model, not only the code for the model, but also the trained weights, because you know, in theory there will always be an open source community that publishes the implementation of a paper, right? So that's one part, but also publishing the trained weights of the model, or different models, small, medium, large, or whatever, is a huge deal, because the architecture of this model is really a basic transformer model, right? But the thing that they have done here is engineering a data set that is really representative, and they have done a lot of cleaning up of the code. For example, it was a really tedious process. I mean, they really went through and defined some brackets that they want to remove. They defined, I think that was manual labor, that they find those words like won't, and it will be replaced by will not, because otherwise the regex will get confused here. So it's a lot of manual labor to really get the data set up and running, to clean the data set, encode them, and stuff like that. So it's really cool that they've published all those. I'm talking too much again. I hope you've enjoyed this video. If you have, please like this video, it really helps out a lot. Subscribe if you want to see more videos like this, or on the topic of machine learning, or machine learning student, or engineering life. And with that said, as always, thank you very, very much for watching, and I will see you guys in the next one. Bye!